Somewhere under the field you last walked across, there is a steel pipe carrying crude oil. It is buried, welded shut, and coated, and along its whole length there is nothing that can feel a hole, no sensor in the trench, no wire on the pipe, nothing that reacts to oil escaping. Yet a leak in it will be found. I'm Alex, and this is Unseen Systems. Zoom out, and the reason is arithmetic. The American section of the system this pipe belongs to runs about 1,900 miles. You cannot line 1,900 miles of buried steel with detectors and keep them working. So the leak is not sensed. It is inferred, worked out, from numbers, in a building that may be several hundred miles away. That inference is the whole safety system, and when it fails slowly. On one American line in 2010, a rupture stayed unrecognized in the control room for over 17 hours, and the federal accident investigators, the National Transportation Safety Board, the NTSB, put the total release at roughly 840,000 gallons. Nobody died. Every number here that carries their initials is theirs, not the pipeline company's. So here is how the arithmetic works, and it is simpler than you would think. At the station where the oil goes in, a meter counts the volume passing it. At the station where it comes out, another meter counts what arrives. Two counters at two ends of a buried pipe, both running all the time. That is the entire measurement. Then a computer subtracts one from the other and watches the difference. It has to correct both readings first, because oil is not a fixed thing, it swells when it is warm, and one batch of crude is denser than the next. So real-time pressure, flow, temperature, and density all feed the sum. Pressure is an input here, not a second detector. The industry calls this computational pipeline monitoring. Computational, the monitoring is a calculation. And the balance is only one way of noticing. The investigators name four more alongside it. The control room's own operating display, supervisory control and data acquisition, or SCADA, the screens and readouts the operators work from, which carry their own leak triggers. Aerial patrols flying the route, batch tracking following each slug of product down the line, and an emergency hotline for calls from outside. Notice what all five have in common. Not one of them is a leak detector. Each produces a signal that somebody has to read, and they all land in the same place. A list of alarms on one screen, in front of one person, alongside everything else the line is doing that evening. The standard for that calculation is written by the American Petroleum Institute, API, the oil industry's standards body, and it is blunt about who decides.
The causes of the pipeline company CPM alarms are not usually determined by a separate piece of software, but by the pipeline controller or CPM support person.
Now the hard part. A difference in the balance does not say leak. It says volume is missing, and there is an innocent way for volume to go missing. If the liquid does not completely fill the pipe over a hill, say, where the line changes elevation, a vapor bubble opens up inside it. The investigators have a name for that.
Column separation is a condition indicating a mixture of liquid and vapor. A vapor bubble exists in the pipeline. Column separation usually occurs at changes in elevation or where liquid does not completely fill the pipeline.
So draw the same stretch of pipe twice. On the left, a vapor bubble at the high point. On the right, a hole in the underside. Both remove liquid from the balance, both drop the pressure, and the pressure is not a second opinion here, it feeds the same sum. So the calculation cannot tell them apart, and the cure for one is the catastrophe for the other. To clear a real bubble, you raise the pressure, you push more in. If the void is a hole, pushing more in is the worst thing you can do. So why is the system built to leave that decision open? Because the arithmetic has a noise floor, meters drift. Temperature moves the volume. A different crude changes the density. If the computer alarmed on every small difference, it would alarm constantly, so it needs a tolerance band, and a slow leak can hide inside that band. Which leaves a system that can tell you something is wrong and cannot tell you what. A person has to pick between two explanations that produce the same picture, and people are not wrong for a fixed length of time, they are wrong for as long as they are allowed to be. So the real safety device is not the software, it is a clock. After an earlier accident, the company that operated this line wrote itself a rule, and it is worth being precise about whose rule it is, not the regulators, the operator's own procedure. If a controller sees pressure or flow behaving strangely and cannot establish a reason within 10 minutes, the line is shut down, not investigated harder. Shut down, isolated, and only then worked out. Here it is, in the company's own words.
If an operator experiences pressure or flow abnormalities or unexplainable changes in line conditions for which a reason cannot be established within a 10-minute period, the line shall be shut down, isolated, and evaluated.
And the reason there is a 10-minute rule at all is itself a failure. In March 1991, the same company ruptured a different line at Grand Rapids, Minnesota, and spilled 1.7 million gallons. The control center read those alarms as column separation and instrument error and kept pumping into the ruptured line for more than an hour. The 10-minute rule is what came out of that. 25th of July, 2010, just before 6 in the evening. A 30-inch line called Line 6B ruptures in a wetland in Michigan during the last stages of a planned shutdown. The crack was not new. A 2005 assessment, together with the company's own repair criteria, had left 6 crack-like defects in this pipeline unrepaired, from 9 inches to nearly 52. The alarms did come. The investigators found that the leak detection and supervisory control systems generated alarms consistent with a ruptured pipeline on the 25th and the 26th of July. The staff read them as column separation. And look at the ground. The report notes the Marshall area is relatively flat, without significant elevation changes, and changes in elevation are the first condition that definition names. Then the line was restarted. Just after 4 in the morning, oil was pumped for about an hour. At 20 past 7 again for about 30 minutes. In those 90 minutes of running, the investigators estimate 683,000 gallons went into the ruptured pipe, 81% of everything that was ever spilled. And the pressure never came up. It should have, it did not. So how did they find out? Not from the balance and not from the screens. At 11:17 the next morning, a gas utility worker who had seen oil on the ground telephoned the control center. The smell had been reported hours earlier, from about 25 past 9 that evening, but those calls went to the county emergency dispatchers, not to the pipeline. The release continued for nearly 14 hours after that first odor report. The investigators put the probable cause as corrosion fatigue cracks that grew and coalesced from crack and corrosion defects under desponded tape coating, producing, in their words, a substantial crude oil release that went undetected by the control center for over 17 hours. And the finding names 2 parties, so both belong on the sheet. The board found pervasive organizational failures at the pipeline company. It also found a contributing cause on the regulator's side. The Pipeline and Hazardous Materials Safety Administration, PHMSA, the federal pipeline regulator, with weak regulation for assessing and repairing crack indications and ineffective oversight of 3 named areas: integrity management programs, control center procedures, and public awareness. The regulator issued a corrective action order and a notice of probable violation. The company replaced sections of Line 6B and changed its training, its integrity program, and its control center. A federal Pipeline Safety Act followed in 2011. Continuing costs, at the time the report was adopted, were put at over $767 million. About 320 people reported symptoms consistent with exposure. So put the whole thing back together. A buried pipeline is not watched, it is calculated. Everything anyone knows about the inside of that pipe arrives at a desk somewhere else as 2 numbers and a difference, and the difference is honest but mute. It will tell you that oil is unaccounted for, and it will never tell you why. The interesting failure here is not a broken sensor. There was no sensor to break. Which is why the last line of defense in this system is a sentence in a procedure rather than a piece of equipment. Somebody writes down how long a person is allowed to stay confused, and after that the line comes down whether or not anyone has worked out what is happening. That rule is cheap. It is also the only part of this that does not need the ambiguity resolved before it acts. Next time you cross a field or a wood, look for the marker posts, yellow or orange, a warning triangle on top, standing in a dead straight line, usually with a phone number. They are signs, not instruments. Nothing at that post is measuring anything. Whatever is happening in the pipe beneath it is known, if at all, in a room a long way away. Thanks for watching.